All right. Now we're going to do question 4. Question 4 asks us which value is the absolute minimum, and is that just another word for local minimum? And this is something that we've actually already found with 12C, I believe. Yeah, 12C. Yeah, we found the local minimum, we found the local maximum. And the way we did it is that we first, whatever the function is, right? This is the function. Follow this blue thing, I guess. Okay, so this is the function, and then the first thing that we did is we differentiated it. Then we found the critical values, and then whatever the critical, no, we found the critical points. Sorry, we found the critical points, and we don't really need to do factorization in this one, but for that question, question 4, and the only thing we need to do is uh apply it to the original function. Why? Because we've they've already told us that we need to find the local minimum. We don't have to figure out whether or not it's a local minimum or it's a local maximum. They've already told us that the one thing that we have to find is local minimum. So we don't need this step. We don't need this step, and we can immediately just plug it into the differentiated different oh no, we can just immediately plug it into the original function. Okay, now I'm gonna remove that. So it's a little bit more aesthetic later. Okay, step by step then. Okay, step by step. 4. Step by step. First, differentiate. Differentiate. How do we differentiate it? It will become. I'm gonna put it on this side because I don't wanna ruin the aesthetic. I wanna do the aesthetic. Actually, a differentiated function is just one. What is it gonna be? What is it gonna be? The symbol. It's gonna be this, that, and an x will equal to, write it here. I'll erase this for now. Write it here. So d over dx by differentiation. Yeah, by differentiation. Differentiation. D over dx 5 is equals to 0, because a constant will always be 0. And then d over dx x, we've already done with this, now we're going to do that, will equal to 1 will equal to 1x, 1 over 1, 1 minus 1 will just equals to 1. And then lastly we're going to have 16 times d over dx x negative 1, remember, and then it will be negative 16. Okay, sorry, let's do it slowly. 16 times negative 1, because, or no, 16 times negative 1 x negative 1 minus 1 will become negative 2. So then 16 will be multiplied by negative 1 x negative 2. So it will become negative 16 over 2. Right? We've already differentiated. That will be 1 plus, no, 1 minus, because it's no longer plus, it's negative now. 1 minus 16 over x square. That will be the differentiation. And I think I'm gonna just erase this. I'm gonna erase this. After we differentiated, what is the next step? The next step is to find the critical values. And finding critical values means that we have to make sure the whole entire equation is equal to 0. Find critical values. Critical points, sorry. I don't know why I keep calling it values, but it's called critical points, which means that f, the derivative of fx, is equals to 0. It means that 1 minus 16x squared is equals to 0. Then we can move one to the other side. Will become negative 16x squared equals to negative 1. We can cancel this out because both is negative. So then that'll just leave us with 16x squared equals 1. Then it will be 16x squared. Then to get rid of the x squared, remember, we just have to do x 16, which is equals to 4. So x is equals to 4. Now, the last thing that we have to do is to apply it to the original formula. So apply to original formula. Sorry, I can't write it anymore. Which is 5 plus... Okay, let's do it properly. Then equals to 5 plus 4 plus 16 over 4. Okay, that will equals to 5 plus 4 will be 9 plus 16 over 4. 16 over 4 is 4, 8, 12, 16 will be 4. The answer is 13. So the answer is D.